Today we are going to be changing fractions to decimals. We have two types of fractions we're going to be working with. Common fractions, which are when the numerator is smaller than the denominator. For example, like 5/8. But we're also going to be looking at improper fractions, which are when the numerator is larger than the denominator. For example, 11/4. Let's start with common fractions and talk about what the answer will be like and how we do this. When changing common fractions to decimals, you need to understand that your decimal will always be less than 1. To change a fraction to a decimal, and we know that fractions are division problems, to change a fraction to a decimal, we're going to use Tae-Bo. Remember, when we talk about Tae-Bo, it stands for top in, bottom out. So you're putting the top number inside your division symbol and your bottom number outside the division symbol. This is going to be the same for both common fractions and improper fractions. Okay, so let's set this first one up. We're talking about 5/8. We have our division symbol written down. I put the top, the 5, in, and the bottom, the 8, out. So I'm dividing 8 into 5, and this right here tells you why it's always going to be less than 1. Because if your denominator is bigger than your numerator, it's never going to go into that whole number that you have written down. So we're going to start right here, and we have to add a decimal like we've learned before in both the problem and the answer. And then we're just going to add zeros after the decimal until we find that the answer either repeats or terminates, just like in our last lesson. 8 goes into 50 6 times. 6 times 8 is 48. Subtract, I get 2. Since I haven't terminated or found a repeating answer yet, I add another 0. Bring that 0 down. 8 goes into 20 2 times. That's 16. Subtract, I get 4. Still, no pattern. Didn't terminate yet. Add another 0. Bring that down. 8 goes into 45 times. 5 times 8 is 40. When I subtract that, I get 0. So at this point, my decimal has terminated. So my final answer, 625 thousandths, and it is terminating. So the process is going to be the same for all fractions changing to decimals. The only difference when you're working with an improper fraction is that your decimal will be greater than 1. Okay, so we're looking at 11/4. We still use Tae-Bo. So we know that the 11 will be in and the 4 will be out. Top in, bottom out. 4 does go into 11. It doesn't go into 1, but it does go into 11 2 times. So we have that whole number there, and that little 0 looked funny. So I'm just going to put the 2 there. Notice it goes over the second one because the 4 is going into 11, not the first one. So 2 times 4 is 8. Subtract that, and I get 3. And because I do have a remainder and I'm changing this to a decimal, now I add a decimal, just like in the other problems, in both the problem and the answer, and a 0. And then I continue my division until it either terminates or repeats. So 4 times 7 is 28. Subtract there, I get 2. Still hasn't ended yet. Add another 0. Bring that down. 4 goes into 20. 5 times. 5 times 4 is 20. So we end at 0, which means my answer has terminated. So 11/4 is 2 75/100, and it is a terminating decimal. So let's try one more together, and then we'll give you some to try on your own that you can come back and check to see how you did. So, first example will be 5/9. Now, 5/9 is a common fraction, which means the numerator is smaller than the denominator. So we know that our decimal will be less than 1. I put the top in, that's my 5, and the bottom out, which is 9. 9 does not go into 5, so I add a decimal and a 0. 9 goes into 50. 5 times, that's 45. Subtract, I get 5. Bring down a 0. 9 goes into 50 5 times, that's 45. And now we can see what's going to happen here. Add another 0, bring that down. 9 goes into 50 5 times. What I need you to do and make sure you do is keep dividing until you can truly commit to the repeating decimal. Too often what happens is people will stop the division and they really haven't found the entire repeating part yet. So when I look at this problem, I see that it goes 0.555, but the question is what number is actually repeating? Some people want to write 55 and put a line over both of them, all 3 5s and put a line over all 3 of them. That's not really the case. It's just the 5 that's repeating. So we have 0.5. We put a line over just the 5. Just one 5, not any others. And we know that that is repeating. It did turn out less than 1, like we were supposed to. All right, let's give you another one. You try this one on your own and come back and see how you do. Let's do 27/15. Now in this one, you're going to try this on your own. You are dividing by 15. It might be a good idea off to the side to write your multiples of 15 so you remember how to divide by them. So you would do 15, 30, 45, 60, 75, 90, 105, 120, and 135. You need 9 of them because the biggest number you could get when you're doing your division is 9. All right, try it out. Let's see what you get. Okay, welcome back. Let's try this out. Put the 27 on the inside, top in, 15 on the outside, bottom out. 15 doesn't go into 2, but it does go into 27 one time. Take that 15. Notice I put the 1 over the 7 because the 15 went into the 27. I subtract 27 minus 15 and I get 12. Can add a decimal in the problem and the answer and a 0. So I'm doing 15 into 120. Oh, 1, 2, 3, 4, 5, 6, 7, 8. I like that I had that off to the side. 8 times 15 is 120. And I get 0. So it terminated. So I do have 1.8, and that is my terminating decimal, or 1 8/10. Let's say, for example, and this is more for tomorrow, but let's say, for example, we were asking for money, or you were dividing this because it was a money situation. Think about what you would change 1.8 to make it look like money. Is that $1.08? It's not. So I just want you to kind of start thinking about the fact that if this were written as money, you would have to add that extra 0 to make it $1.80. Those two things have the exact same value. When we're talking about money, though, you have to go to the 100th. This isn't a money problem, though, so it's just 1.8, and it is terminating. All right, try this next one. Example 3, you are going to do 25/11. Again, write those multiples off to the side if you need to. See you in a minute. Okay, let's see how we did. You had 25 in and 11 out. 11 does go into 25, doesn't go into 2, but it goes into 25 2 times. That's 22. Subtract to get 3. Add a decimal in both the problem and the answer, and a 0. 11 goes into 30 2 times. That's 22. Subtract to get 8. Add another 0. Bring that down. 11 goes into 80 7 times. That's 77. Subtract to get 3. Bring down the 0. Another 0. 11 goes into 30 2 times. That's 22. So at this point, and subtract to get 8, at this point, a lot of people notice that there's going to be some sort of pattern. It is repeating. But then we have people that make mistakes by saying it's just the 2 that's repeating, or they think it's 2 7 2 that's repeating. What I'm saying as far as the division goes, you need to keep going until you're positive you know what that pattern is. So in this case, you really should just do one more just to make sure. I bring down that 0. 11 into 80 is 7. Now you can see that's what's happening is 30 minus 22 brings you 8. That's 80. Minus 77 gives you 3. That's 30. Minus 22. So you're going 30, 80, 30, 80. And that's going to happen forever. So what is repeating in this problem? The 2 and the 7 are what you should show repeating. So you write 2 and 27/100ths, and then you put a line over both the 2 and the 7. It's not a dash over the 2 and a dash over the 7. It's a line over both of them together. And I know it's kind of redundant to write repeating and put the sign because it's both of them, but just so we know that you understand that that's a repeating decimal, please write that word. All right, one more example, and then you can get your worksheet. Our last example is going to be 1/12. Now, I think this one's kind of tricky. Let's see how you do. Try it out. Come on back. All right, let's see how we did. We put the 1 on the inside and the 12 outside. And you knew it would be less than 1 because it's a common fraction, not improper. So I'm going to add that decimal in the problem and in the answer and a 0. So let's see how many of us caught this part. 12 does not go into 10. So in this case, that is 0. But because it's after the decimal, you have to show that place value. So that 0 has to be there. So 0 times 12 is 0. Subtract, I get 10. Bring out another 0. So now it's 12 into 100. Now, did you write your multiples? 12, 24, 36, 48, 60, 72, 84, 96, 108, just to help us out, make it faster. 12 goes into a 100. 1, 2, 3, 4, 5, 6, 7, 8 times. That's 96. Subtract to get 4. Still working. Bring down another 0. 12 goes into 40. 1, 2, 3 times. That's 36. Subtract, I get 4. Bring down another 0. 12 goes into 40 3 times. 36. Commit to the problem. Make sure you go until you truly see the pattern. 12 goes into 40 3 times. All right, so it is repeating. In this one, you have to recognize that the 3 is the only thing repeating, so the line should only go over the 3. So did you get the two tricky things? Did you notice that there had to be a 0 first? And did you just write the repeating sign over the 3 instead of everything else? All right, so let's practice this on our own. Good luck.